just hand up the quiz. I'm going to want these back. You don't get to keep them, but I want them back. Okay. At least take a look at them. We're going to go through every answer right now. I'm going to speed kind of through it. So, let's see, Trish. See, Freda. Sadie. Oh, sorry. Him. Balaam. Joel. There. Page. And we got one. Okay, so I'm going to pop it up on the board here. We're going to go through it just to make sure. Okay, all right, here you go. Okay, it's out of 42, so you can just see this. In fact, I'm going to put the lights. Okay, all right, it's out of 42. Limitless flat surfaces. A flat surface is a plane, so it's got to be a parallel plane. We don't have anything like skew planes or anything like that. They don't even have intersecting planes. The only one that with plane is parallel, so it's kind of your only option. Angles that are in between the parallel lines, they're in between, but they're on the one side of the transversal. There's those same side interior, because they're on the inside, they're in between. The transversal is the line that intersects two other coplanar lines. They have to be coplanar for a transversal to go through them both. So, and they'll go through at different points. Coplanar lines are on the same flat surface that never touch. If they're on the same surface and they don't touch, they have to be parallel. If they're on different surfaces, they could be skew. So that's the idea. So they're coplanar. So that's what makes them parallel lines. The belief that parallel lines do not exist is non-Euclidean geometry. Euclidean geometry believes that parallel lines are that exist. And then non-adjacent angles, so angles that are not next to each other, that are in between the parallel lines, so they're interior and they're on the opposite sides of the transversal, are called alternate interior. So there you go. Those are like the main words we've discussed a lot in here. I didn't try to pick any random words. We basically used a lot of the terms that we've done before. Okay? They're 1 point each. That's kind of how it works. I didn't pick any real crazy ones. I just kind of picked the main ones. Okay? All right. Yeah, the type of angles for number 2, like what their pairs are. As you can tell from my picture, I kind of labeled what they are. Like these are exterior angles, these are interior angles. That kind of tells you kind of what your name should be. Okay, so like 2 and 6, well, they're a type of interior. They're alternating, because they're alternating over the transversal. They're on the different sides. 3 and 1, these are corresponding, because one's interior, one's exterior. So they have to be corresponding. It's the only pairing that we could have with that. 2 and 3 are same side interior. They're on the same side of the transversal. They're interior. 8 and 4 are alternate exteriors. They're exteriors. They're alternating. They're not on the same side of the transversal. And then 7 and 5 are corresponding, because one's interior, one's exterior. So that's how I like that. That's how I like just defined like what those names were. Okay, there was no other options. Thinking back to like what's going to be coming up on the semester test that we have, then you'll see the practice guide today. This is definitely one of the questions that'll be on there. That is a major thing that we spend a lot of time on. So it'll be a picture almost identical to that. I'll ask you a series of pairs. You have to tell me which one's which, and it'll even give you the list of the types of angles you have to pick from. Make sense? Once we get to the practice guide today, you'll see that. That literally is one of the questions. Okay. Number 3, scroll down here. Okay. You had to find the values of x and y. We'll define x first. These two are supplementary. They're side by side. So these two have to add up to be 180. So the only way that these add up to be 180 is if x is 125. Because that's what I actually do. I add to make 180. So I just subtracted the 55 across. And now to find the other one, these are alternate interior and they should be equal. You just had to know that they can hopscotch. Multiple ways of doing it, but that's the idea. There were 3 points because there was actually one line of work you had to do, and then you had your 2 answers. That was the actual idea that you had. Okay? All right, number 4. This one, it wasn't like inherently as simple as the last one, but if you just thought about it, a lot of people got the first letter right, X. A lot of people did. Not everyone, but a lot of people did. The problem is they couldn't find what Y is, and they didn't really think about how simple it was. Okay? The idea was that you only had 2 parallel lines, just these 2. So knowing that these are parallel, you had same side interior, same side interior. The problem is you didn't know what this angle is. So you can only work with these 2. These 2 have to add up to be 180. That's what same side interior are. They're supplementary. So this has to be 60. So knowing that my x is 60 right away, because these had to be supplementary, I could plug that in here and plug that x in. Because that x is the 60, so 3 times 60 is 180, and they subtract 70, so that's 110 over here. That's 110 right here. And that makes this angle have to be 70, because these have to add to be 180, because they're side by side. So 110, this has to be 70, and so this angle is 70, so I just set it equal to 70, and you can actually see me solve it. Right? You know, subtract the 40, divided by 3. So it wasn't like meant to be like difficult, it was just you had to think about, okay, I have to plug the x in and actually use that. This is a perfect type of problem that I could definitely put on the practice, or the semester test, I should say. It'll be a question where, you know, either like 3 or 4 where you have to find a value of x. That was a major concept we were supposed to learn this semester. Where you're given a picture with parallel lines and you have to find a missing value on it. So like those types of questions are free game, okay? Or one that's very close to it. I think there was one on your practice guide, I think it was like on the back page, correct? Like the third page, it was a problem almost identical, like that could be one of the problems that I could pick from. Okay? All right, questions, comments about how to do that? Okay, moving on. Again, first page out of 19. Okay, second page here. You had to find slope. Okay, just remember what your slope formula was. It's actually still on the board. Still right there. I haven't even erased it yet since December 22nd. It's on the board. You subtract the y numbers, you subtract the x numbers, and you stack them on top of each other. It's right there. Okay? So the y numbers are these two, because it goes alphabetical order, x, y. So I subtract the x number, so -5 minus the 2, and I subtract the x number, -2 minus the 6. So as I do that, that's -7 on the top, this makes -8 on the bottom, and the negative signs are canceled. That's your slope. I had a lot of people telling me that the slope was this. And they circled it. What is this?
That's a coordinate.
That's a coordinate. Slope is not a coordinate. It's an actual fraction. It's a fraction that represents the tilt of a line, the rate of change of a line. So I had a lot of people tell me that the coordinate, that doesn't make any sense. 7, 8 is like 7 over 8 up. It's a dot. It's not, this doesn't represent slope. So if you figured out, like, are you wondering why you got that wrong? You didn't give me the right form, one of the fractions. Okay? I know what you're trying to get at, but you have to give me the fraction. Okay, number 6, same exact idea. You had to find slope. They just didn't give you a picture this time. So you had to know which one was your x and y. So these are my y's, these are the x's. So I subtract 1 minus 1 on the top, and then the 3 minus the -2 on the bottom. So the 2 negative signs would cancel out here, so this would actually make 3 plus 2, which is 5, and on the top you get 0. 0 divided by anything is 0, that is a 0 slope. It's a 0 slope function. It's horizontal, that type of thing. It's not going up, it's just running, but it's 0. Like that's what I wanted, I want to see 0. Okay, I had a lot of people like, they were telling me that 0 divided by 5 is 5, and that's not true. Okay, 0 divided by anything is still 0. You have nothing. You divide into 5 parts. Okay, that's number 6. Same exact idea, I just didn't give you a picture. Okay, number 7. You had to graph the lines That's number one. You have to graph the lines that satisfies that condition, which that's the picture over there. You can see that that's like a couple points right there. Then you also had to give me the equation for that line, the one that satisfies the condition, and it had to be in point slope. That was an extra point. This problem's worth 3. It was 2 points for the graph. You can see it there, and it's 1 point for this because this is one thing that you had to find. Okay. All right. So the first step you have to do, we had to be parallel to BC, so I had to draw BC first. So here's B and C. The coordinate is 1, 3, and then 4, 5. So there it is. And what I did is I found slope of that. I subtract the x's, I subtract the y's over the x's. So that was -2 over 3. And the next sign canceled, so it was 2 over 3, which makes sense. It's going up to the right, so it's positive slope, rising 2, running 3, that type of thing. And I had to be parallel to that thing, but I had to go through this coordinate, 2, 5, 2, -5. So I had to go 2, -5, go up 2 over 3, up 2 over 3, up 2 over 3. That's how I was drawing it. And then the idea is I had to come up with the equation for it, and it had to be in this form. This form is actually written on the board. M is my slope, which is the 2/3. And then I had to pick one of the coordinates, that's my x1 and y1. So x1, y1, this is my x1, this is my y1. So it's x minus the x1 number, so x minus 2, and then y minus the y1 number, so y minus a -5, which is +5. The two negatives cancel. So that's what I was looking for. A lot of people were not graphing it right, they were just like picking a random way to draw it. They got A right, but they just didn't know where to go from there. You had to find slope, had to know how to draw. Had to be parallel. This type of problem is definitely a problem I'm going to put on the semester test. Something that you have to graph, and you have to come up with the equation for it. Something like that. It's a perfect type of question. It can be parallel, it can be perpendicular. There'll be one of those, and you'll see it like once we get to that practice test. Okay? All right, questions with that? Okay? All right, next question, number 8. This is worth probably the most points in the back, because you have to do almost all the work for this problem. Not just graphing and coming up with the equation, which is simple. This one you had to find slope, you had to come up with the equation, it had to be in slope-intercept form, which is not easy. Okay, because that's the form you see on the board there. You had to actually find the y-intercept. So what I did is I just put it in this point-slope form and I rearranged it. And this is what took the most time. It took actually like 4 lines of work to do it. Okay, so to find slope, y minus the y, x minus x, so 6 minus -4 is 6 plus 4, 2 minus -5, which is -3, and this is your slope, which is a goofy slope. It's dropping 10, running 3. I had a lot of people said that they were counting like it went down 3 over 1. Like that's what a lot of people were saying. If that was your slope, it should keep working, which it doesn't. So that's not your slope. It was a goofy number. You had to actually subtract, you had to actually use that formula to see it. So then what I did is I put it in a point slope form, so I picked one of the coordinates. So I picked this one, x1 and y1. So x minus the x1 number, y minus the y1 number, and I put my slope in. And what I did to make this slope-intercept form, which is this form right here, I had to get the y by itself. So basically what I did is, what you could do is you could just add the 6 over, but the trick was I need to get rid of the fraction and everything to make it a lot easier. So I multiplied both sides by 3. If I multiplied this side by a -3, the 3 would be gone. Multiplied this side by 3, and you can actually see me do my work there. I took it times 3, both numbers, and so I got rid of the fraction on the one side, and I had the 3 over here, because I don't want the fraction. I add the 18 across, which is really easy to add with that -20 or the +20, because I distributed the 10 through. And then the last step that you can see here, I just divided everything by 3. So that way I got the y by itself and I have the fraction. I had a lot of people like actually dividing this on a calculator. I don't mind, you could use a calculator. So a lot of people were just using decimals. They weren't worrying about it. No, I had a decimal right here, that's fine. As long as you knew what you were doing. This is the one way that I've done it. It probably may not be the way that you chose, but that was the answer I was looking for. And I think 38 divided by 3 is like 12.6 or something like that. Alright, so that's number 8. Okay, this type of problem is a lot like the last one. I mean, that's something that you should expect, where you have to graph something, come up with the equation for it. Okay, questions, comments about that question? Okay, now obviously unlike the semester test, I would not give you something that difficult. That was a difficult problem. Semester test is just, can you find the slope? Can you plug it into a basic equation? And can you rearrange? It wouldn't be something weird where it has some weird numbers like that. Because distributing didn't make that any easier. Distributing is fraction. Usually it does, but it didn't. Okay, moving on. Okay, last page here. Okay. This one's a lot like the problem we did earlier. We had to look at a picture and find X and Y. That was from the first page. What was that? Problem number like 3 and 4? Those two. You'd find X. Well, the trick was on this problem, you had to realize these two angles are equal. They're alternate exterior. The theorem was theorem 3. I didn't put it in there. 3.3 or 3.5. 3.5. Okay. It was these two. They're converses of each other. Okay. 3.3 was the alternate exterior angle theorem, and 3.5 is the converse of it. The idea was that since those angles are equal, you set them equal, like I'm showing you there. 3x minus 14 is equal to 2x plus 25, and then I just solve for x. I move the x's over, move the 14 over, solved, and my x was 39. I had a lot of people like plug it back in. They plugged it in, and they figured out what was it, like 109 or something like that, 103. A lot of people like plugged the 39 back in here. You didn't have to. But I was looking for the postulate or theorem, one of those two, and the actual work. I had a lot of people tell me like random postulates, like postulate 3.4, postulate. No, it's one theorem. You gotta know. Okay, and then number 10, you had to do construction. It was just the construction, number 5 that we did on the board, you know, that week when we were doing all the construction reviews. It was that last two constructions of perpendiculars. You had to find the segment that represents the distance indicated on this diagram. They wanted the distance from H, this H right here, to the line FG. They wanted this stick right here. That's a distance. The distance is the shortest line going. So the trick was you just draw the perpendicular. So I rotated my paper. You take your compass, you draw a smiley face, and then you use the corners of the smile to draw the X's out here. And you draw that line straight down. You can actually see, like, I didn't erase anything when I used my compass. My compass was sliding all over the place, but I mean, I was at least in the ballpark. That's what I was looking for. That is the distance from H to this line, the shortest distance. That's what perpendiculars give you. Okay? I'm not going to have any constructions on the semester test. I can guarantee you that right now. I'm not going to do it. It takes too long. I don't want to put you in this situation. Perfect for a test or construction, but not for a semester. Okay, I'm going to walk around and collect those. This is mine. You can at least see your score. If you're going to retake it, you don't need to tell me. You don't need to email me. Just come in the morning and we'll go over what the prime is. So make sure that you understand what to do. And then you can retake. Now, when you retake, it'll be a completely different test. It'll have different numbers, you know, but it'll be the same concepts. It won't be any easier or harder. It's just different. That way you have to show me that you've actually learned something. So again, you have a week from today if you choose to retake it. So by next Tuesday, if you wish, you can come in the morning and do that. Okay, we good? All right, let's take out your notes. Let's talk about your practice semester test here. All right, here it is. And again, you'll get one of these on Thursday this week. You can actually like kind of work on, see kind of what it is. Okay, usually what I do is I give you points for completing it in class. So if you're taking notes, you at least have the majority of it. I always give you some time at the end of classes on Thursday, Friday, the kind of the lead-up days where you can actually work on this. So you can see, do I know this? Is there something else I need to ask questions on? This looks really close to what your semester test is. The same number of questions. All I do is basically, I just, maybe pick a different letter for this plane, or I pick, maybe I ask for how many lines are labeled in the picture, that type of thing. But it'll have a picture, and you have to answer a series of questions. So thinking back to chapter 1, what was the major thing we were learning? It was vocab terms, and notation. Did you know what a plane is? Do you know what a line is? Do you know what a point is? Do you know what an intersection is? That type of thing. So that's what I'm having on problem number 1. So the goal today is to go through about 2 or 3 questions, maybe 2, and then we'll kind of see where you're at. Okay? All right, so let's take a look at this one. So we have 2 planes here, here and here, and again, semester test day, if it doesn't show up pretty, I always put it up on the board so you can see it on semester test day. Oh, and word, just to warn you, I don't care if you're gone Thursday, Friday this week. You still take it Monday, Tuesday. You don't have that option, where it's like, oh, I was gone. Doesn't matter. You have to take it Tuesday. So you better be mentally prepared, okay? Because I know I always have somebody that like will skip class purposely on Fridays thinking that they can get out of the semester test. It doesn't happen. You take it anyway. So that's just a warning to you. So keep that in mind, okay? All right. So identify the following problem, okay? Name the lines that are only in plane Q. So this is plane Q right here. This is the plane. They label it with a capital letter in the corner. This plane up here is plane R. Okay. So what are the different lines in this plane? The lines that are actually on the plane itself. Can you name 2 of them?
NG.
Say it again.
NG.
Not NG. Actually, just N. Because N. Because N is not a coordinate. It's actually the name of that line. So it's line N. So you'd actually say line N. And what's the other line? Q. That one you could actually name something else. You could actually call this line HL with that little arrows above it. When I name these, I usually use the italicized letters. So I would say like line N and line Q. That's like how I would do it. It's the easiest way to write it so I don't mess it up. If you choose to use the 2-letter system, like on this line Q, you choose to use HL, you have to write it like this. You have to have the arrows above it. If you choose to use the cursive letter, you don't have to. It's just one single letter. Okay? That's why I always choose to do these. But if you choose to do the 2-letter system, you have to use the arrows. If you forget the arrows, I kind of wrong. All right. Okay, question.
For problems like that, do we have to use lines that are completely shown, or could we do things like GP?
Oh, that are like actually, I'd prefer on semester test day you choose the ones that are actually drawn.
Okay.
Okay, good question. I want the ones that are actually drawn. Because thinking about the chapter 1, you didn't have that luxury of like picking ones that aren't drawn yet. So yeah. So I'll kind of warn you on semester test day, I want the ones that are actually drawn. What about line DM? Is that one on this plan? Okay. All right. We'll continue tomorrow. Just kind of pick up right there. Thursday, again, you get one of these in hand where you can actually kind of throw it out. Kind of keep that in mind. Semester test is next Monday, Tuesday for us, no matter what.
Where are they going?
Sadie, guess what I was going to make you? So, oh, you oh, really? Oh, for it. I don't know, some people are different. Like,